Chat, welcome to the stream. How are y'all doing today? It is Wednesday, December 10th of 2025. We are back for yet another stream. It's gonna be a quick stream today because I gotta take a friend to the airport. So we're on a time crunch. We'll see if we can get through today's advent of a code problem quickly enough. But let me say hi to everyone who's here. JJMC was first. Major Tanya's also here. Simply Scott, good to see you again. Kevin's here, who says yellow for some reason. Balwada, hello, welcome. Hepta5's also here. Some EU-friendly shoveling time. I did have to shovel today. I didn't think I was going to have to shovel because it was warm, but it started freezing raining, and I was like, I do not want a 1-inch thick sheet of ice on my driveway. So I shoveled this morning. Sky Cosigner says, hey, first time catching you live. Been a fan of the VODs channel for a while. Awesome. Welcome. How you doing? It's weird. Usually Twitch will tell me first time chatter, but this is your only message. Strange. Welcome to the stream. How's it going? Major Tanya's on a 35 stream streak. My goodness. When will you make merch? Surely next year I'll make merch. Yeah, I will try and make that happen next year. Maybe not crop tops, but something. Okay, let's do Advent of COD. Day 0 to day 10. We're on double digits. Well, this is kind of a cool looking input. You got some sort of number field and then a bunch of tuples and a set? Maybe? I feel like this one's gonna be a parsing problem. Yeah, I wonder how this is gonna work for... I shouldn't be trying to box myself into SQLite. I've just always have it on the brain. I'm already thinking about SQLite here. My watch is too tight. I'm gonna do this. I have given out stickers at conferences, but I think people want something where they can click button, pay money, and receive it. Sky Cosigner says, good luck with today's problem. I've been stuck on it on and off in my free time. Well, I only have less than 3 hours, so yeah. Crop tops have higher profit margins. Yeah, cheaper per unit of cloth or whatever. A Shiba Inu. Those things are monsters. One of my exes has one. And that dog is crazy. Okay. Indicator light diagrams, button wiring schematics, and joltage requirements for each machine. Back to the joltage again. Okay, so we got squackets for the light diagram. We got wiring diagrams for these and joltages. Start a machine. Its indicator lights must match those shown in the diagram where dot means off, octothorpe means on. The machine has a number of indicator lights shown, but its indicator lights are all initially off. Okay, well, let's take our example since that's probably our sample CODs here. Blah blah blah. You can toggle the state of indicator lights by pushing any of the listed buttons. Is that what these are? Yeah. Each button lists which indicator light it toggles, where 0 means the first, 1 means the second, and so on. When you push a button, each listed indicator light either turns on if it was off or turns off if it was on. You have to press each button an integer number of times. There's no such thing as a half press. Nor can you push a button a negative number of times. Okay. We don't have any half A button presses here. So wiring schematic like blah means that each time you push that button, the first, fourth, and fifth indicator lights would all toggle. Got it. Joltage is ignored for part 1. Spooky. You determine the fewest number of presses to correctly configure all indicator lights for all machines in your list. Okay. You could press the first 3 buttons once each for a total of 3 button presses. Yeah. You could press... This for 4, this for 5. Okay, the fewest is 2. Pressing the last 2 buttons once each. Whew, okay, this is interesting. We have 200 such machines. And some of the machines are quite complicated. Okay. So, I guess one way to do this is just represent these as bit masks and XOR them. It's like... Let's put a 1 in front so that we actually get... So that at least makes the button press operation cheap. And I can't think of a clever algorithm for this, but maybe we just Dijkstra's it. Did you see what I saw in the example input? I did not. Yo, Kegsit with the 20 stream streak. What's up? What's up? Yeah, I feel like we can just sort of Dijkstra's this. I'm... 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It's interesting that... I'm just trying to think about part 2, and I shouldn't be thinking about part 2. I should try and get part 1. Yeah, I guess let's represent these as binary numbers. Do we have XOR in SQLite? I know it doesn't matter. We don't have binary literals in SQLite. Fuck. I guess you can implement XOR like this. Cool. I don't actually need Dijkstra's for this because there's no weights on the traversal, but like it's literally just breadth first search. Like breadth first search probably works, unless there's like billions of presses, but I think these are small enough and these are small enough that I don't think it super matters. The fact that the buttons match the machine in length. The buttons match the machine in length. We can iterate 2 to the end, know all combinations to try. Yeah, I mean the buttons never go past the end. But I don't know. I'm just gonna try breadth first search and go from there. If you started at 0 and iterated up to 2 to the end, you'd have all combinations. So 1 would represent the pressing the last button, 2. Oh, yeah. Yeah, that kind of makes sense. I'm just going to breadth first search because I think the input is small enough that I shouldn't have to do any clever algorithm. But let's do the parsing. I guess we can I kind of want to represent these reversed. So that 0 is least significant bit. I killed your streak. Oh no, S1 cube. Oh no. Does that work? No. Of course not. That would be cool if it did. I guess the this happens first. Oh, we need it in base 2. That one's not that useful because it's symmetric. Yeah. Yeah. So then we need to build these strings, or these integers. See if that makes sense. So we have this. So 3 should be at 0, 1, 2, 3. 1, 3, 2, 2, 3, 0, 2, 0, 1. Okay, that seems fine. And then we whip out our deck. Kevin says, I'm finishing the last 3 centiliter whiskey bottle I got for my advent calendar of 2023. Oh no. Why colored weird? Okay, we have passing test. Am I an Ubuntu enjoyer? Yeah. Damn Windows, I thought he had programmer socks. My grippers are they're free right now. Not for you though. They are unchained by these things you call socks. Let's do a little prediction. Start prediction. We'll give you 30 seconds. We'll be a quick one because I don't have that much time. Gamble time chat. Gamble time chat. Don't do the mistake of showing feet on Twitch. It's happened a few times accidentally in the 7 years I've been on this goddamn platform. But I get it. Oh, Kevin's in the non-gambling regions. Alright. The fuck? Invalid literal for... Oh, I can't type. That's why it wasn't tab completing, probably. It's taken a while. Memory's going burr. There must be one problem that's particularly bad. Or infinite looping. We're gonna kill it before it consumes all my memory. We'll let it get to 50%. No, I think it's time to say that this is not completing. Or it is? JK? No, okay, so this is why you don't use recursion, because it'll just complete eventually anyway. Okay, so pretty slow, but I got there. Action Yam, welcome to the stream. Came from YouTube. Welcome, welcome. Yeah. Part 2, Pythonic says, can't stay today, too many meetings, but good luck on part 2. Thank you, thank you. We got part 1. Let's take a look at part 2. All the machines are starting to come online. Now it's time to worry about the joltage requirements. Each machine needs to be configured to exactly the specified joltage levels. Below the buttons is a big lever you can use to switch the buttons from configuring indicator lights to increasing joltage levels. Ignore the indicator light diagrams. They have numeric counters, 1 counter per joltage requirement. The counters all initially 0. Joltage like 3, 5, 4, 7 mean the machine has 4 counters that are initially 0, and the goal is to simultaneously configure the first 3, the second to 5, the third to 4, and the fourth to 7. The button wiring schematics are still relevant in this new joltage configuration mode. Each button now indicates which counters it affects. Where 0 means the first counter, 1 means the second, and so on. When you push a button, each listed counter is increased by 1. The counter being the joltage counter. So wiring schematic like 1, 3 means that each time you push that button, the second and fourth counters would each increment by 1. If the current joltage levels were blah, pushing the button would change them to be blah. Okay. You can push each button as many times as you want. However, your finger is getting sore from all the button pressing, and you will need to determine the fewest total presses required to correctly configure each machine's joltage level counters to match the specified joltage requirements. There's the fewest number of button presses to correctly configure the joltage level counters on all of the machines. Do we just ignore these now? Or do we still have to take those into account? Unclear. D-Delsp! Whoa! 5 years? 60 years? Thank you for the resub, D-Delsp. It's good to see you again. I hope you're doing well. I appreciate your continued support. How you doing? Good to see you. I feel like there's a lot of reading, but maybe I'm missing that this is actually not that complicated. Saigai Ryan, thank you for the follow. Welcome, welcome. Drugged up dads are weird, man. What? Hello? Verdovan says, are you big on YouTube? How do you have 5,000 GitHub followers? Well, I'm big on GitHub, for one thing. Because I made this thing. And I maintain this thing. And I maintain this thing. And I'm a maintainer of this thing, although I'm pretty inactive on it. Python dev, what am I doing? PyTest dev. I'm a maintainer of this thing. But I have a few YouTube subscribers, a few. Just almost 50K. We'll get there at some point. Saigai Ryan, thank you for the sub with Prime. Appreciate it. Welcome to Subdom. Congrats on your first fancy badge. You're in Texas? Oh, your dad is drugged up. Gotcha, gotcha, gotcha. Nice. Makes sense. I feel like this actually isn't that tough. Unless I'm missing something. Like, do we just ignore the wiring schematics? The lever, you switch buttons for configuring indicators to voltage. Ignore the indicator light diagrams. Yeah, how is this hard? This seems like just apply the same idea, but good luck with part 2. I just Z3'd it. What? I feel like this isn't hard. It's just I feel like I can just depth first this again. Unless the numbers are really large. I mean, yeah, some of them are kind of large. Some of them are kind of large. It wouldn't be terrible. Like, this would be easy to represent in Z3. Like, it wouldn't be terrible to represent Z3. I wonder. But if the biggest number is like a couple hundred, I don't see how this is tough. Verdovan, thank you for the follow. Welcome, welcome. I hope you're doing well. We also have a pretty good pruning condition, which is like if this number is too big, if any of the numbers are bigger than the target, it's not that bad. Our little binary trick is not that useful anymore. But yeah, maybe I just don't get it. Like, I didn't even prune my depth first on states we've already seen. I guess that would be one way to improve part 1. But we're not on part 2. Am I using future? I think it's this video? Yeah. I think it's that video. Check out that video! The other answer is because I'm not running Python 3.14 yet. Not until next April, probably. Oh, we got a hype train. Thank you, chat. Okay, let's just try the dumbest solution and see if we get somewhere. See if we get somewhere. Tuple int s for s and dot split comma. I mean, our buttons are actually the same too. Run this backwards. We want it like this. Oh no, we do want it like this. Oh, hype train finished. You've collected all the tier 1 emotes. Neat. Neat. Am I an OOP enjoyer? No, I'm an OOP hater. Why are you using annotations? Type annotations has nothing to do with object-oriented programming. Right? How is that related? He's trolling? Yeah. But not very well either. Like, I don't... Probably rage baiting? I don't even know if it's, like... It's not rage-inducing yet, so I don't... It's just dumb. We're using an OOP language then? Python is a multi-paradigm language. It doesn't have to be an OOP language. Using text editor, fucking noob. Ayo, true. You don't get it? You can do rage bait by saying that someone else is doing rage bait? Ah, you're rage baiting the non-rage bait. So meta. Should I actually make part 1 go a little bit faster? By doing this. Yeah, I should make part 1 go faster. We'll do the same thing for part 2. Aren't annotations used for name error caused by returning same class from class? That's one reason to use future annotations. Kevin says, also, I didn't leave. I'm just not looking at your code. Fair enough. Fair enough. This becomes more complicated. I guess. Is it possible that there's a button that's out of bounds? No, right? Like this string should always be longer, same length as this one? I don't know if I ever checked that. Well, I guess if we get a key error, we'll know. It wouldn't really make sense to make it out of bounds. I mean, you never know with Eric. Wilfred, got my new internet today. We are flicking back. 1 gig all around. Awesome. Is it AT&T? Fios. Ooh, nice. Should have ran my type checker. What's the my by error? Oh, I forgot a dot 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 on my type annotation, of course. All right, it passes the test. We get to do the little prediction time. Gamble away. I'll give you a whole minute because I'm gonna go fill up my water. I'll be right back. Hello, I'm back. What did our prediction look like? We got Ivan with 10K on yes. We got 127 localhost with 2K 2020 on no. 5 believers, 4 doubters. Pretty split there. All right, let's see what we got. Wolford says I have literally no points. What happened? Also, hello, Ivan. Good to see you. Might as well open up top because I feel like this is going to be kind of slow. Maybe really slow. Yesterday happened, you voted 15K on no and got cooked. That's true. I feel like it's gonna be really slow. I feel like it's gonna be really slow. But how slow? Pretty slow. Pretty slow. Is there a better way to do this? Probably. Yeah, given it's like getting super stuck on the third one. What does the third one look like even? The third one has a lot of very large numbers. Why are there 8 pre-commit tests for a single page file? They all do different things. But not all of them run on the file. Like, these ones aren't relevant. Bob L'Esponge. What? Okay. I'm gonna say that this is never finishing, and so the prediction is no. To save you all the time. It probably would eventually succeed. But we're gonna go with no. Especially because it's probably gobbling the rams. And the problem with this, I believe, is that it has to reach a pretty far depth to actually get the right answer here. And so it's going to generate an absurd number of possibilities. Yeah. So we're gonna go with a no with an asterisk, and we're gonna nuke this. Okay, back to the drawing board. How can we make this better? Also, why does Control-C? Oh, because it has to free all the RAM. Okay. Give it a year, right? Wilfred says, my teacher wore Hermes every single day. What does that mean? I literally only know how to. I literally only know how to say hi, bye, and tell you my name and where I'm from. That's all you need, right? Haha, Python slow, fire emoji, raffle emoji, pointing to user emoji. Yeah. I mean, I wonder. I wonder. I mean, we could throw PyPy at this, but I don't think it's going to make a difference. I could definitely do the first two faster, but... Wilfred says, fuck, I have a meeting in 10 minutes. Anthony, be my sugar daddy, please. What? Wouldn't it have to go the other way? Wouldn't you be my sugar daddy? Real chance, right, and see biceps emoji, rock emoji, screw emoji. Yeah. Yeah, so even PyPy, like, we're never gonna get here. So let's think about different ways we could approach this without doing it with Z3. Because with Z3, it's just a math equation. Wilfred says, no, you definitely have more money than me. I have a shopping addiction. Oh. But you probably currently have more income than I do. Try site that? Yeah. I don't, it's not gonna make a difference. So, looking at these, it's really just a series of equations. And trying to maximize and minimize values. But it's a many variable equation. Kevin has more income than all of us. Kevin also has a wife. Grocery run for Major Tanya. Sounds good, sounds good. All right, I now have 2 hours remaining. So for instance, to get 7, we have to find all of the 0 presses. So it's A times this one, B times this one, C times this one. And I think we would just generate a bunch of equations. Kevin says, I do not. I spend it all on Anthony. FYI, Anthony is rich. I mean, I do. I am well off. I'm not going to dance around that. It's why I don't care that I have a job right now. Or that I don't have a job right now. But we know he's trying to gaslight us. I'm not trying to gaslight us. Why am I failing to dodge the microphone? Is that what you wanted? Kevin and Wilfred? Goddamn. Thank you each for the 5 gifted subs. Well, I guess we don't have no buttons anymore. Don't throw around the J slur, you mean job? Welcome to Subdom, Damonin, Random Dev, Syntax Wraith, RV Santos, Irish, Gamath, Hardy, Startup Me, Jaller FPB, and ArcSign. Welcome, welcome. Kevin says it's fine. I recently pawned Jenny's silver necklace. Oh no. Oh no. Yeah, so how would we write this as a series of equations? Like, how would I think about solving this with Z3? I'm sure there's some like crazy fucking matrix solution to this too. So let's take this like, let's take this this first one here. So we know the only ones with 0 in it are these ones. So let's number the buttons 0, 1, 2, 3, 4, 5. So we know B5 times A 0, 1, 2, 3, 4, 5. Okay, B4. Actually, let's just number them A, B, C, D, E, F. So E plus F equals 3. For 5, we know that B plus F equals 5. For 4, 0, 1, 2, it's C plus D plus E equals 4. And for 7, it's A plus B plus D equals 7. And so then we have a syntax of equations. Cool Mac Blue says, how does the Babby syntax highlighting work? You can read the code. It's actually pretty straightforward. It uses the TextMate engine. Well, I ported the TextMate engine to Python. And so I guess then the question comes, can we simplify any of these down? Like intuitively as a human, I might be able to. I might be able to like solve for F and substitute it into these, although we're only, I guess we're not really reducing variables. It's like we could say, for instance, F equals 3 minus E. And so we could also say that B plus 3 minus E is equal to 5, which is not that helpful. Because we didn't actually reduce the number of variables. We do see D is the only used here. No, it's also used here. Well, that's annoying. C is uniquely here though. Oh no, that can't be right. Oh, I guess. Yeah, that does make sense. And A is uniquely here. But I doubt our input is actually that helpful. Like our input, the buttons are always at least multivariable. Kaiser says Z comma plus forms a group and Z equals forms a setoid. Of course, yes. Wilfred says, this is the first world problem, but I'm gonna complain for a sec. So if you order from DoorDash multiple times in one day, they charge you for all of the orders individually, and then at the end of the day, they refund each of them and charge you the sum of them. What the fuck? What? Is that... How is that not just like a massive waste of financial infrastructure? That seems crazy. That seems crazy. Side note, it takes 2 days to process a refund. Oh. Group is a set with identity, associativity, and invertibility. Setoid is a set with equivalence relation, reflexive, symmetric, and transitive. Kexit, why do you know all this shit but you don't know how to get rebase? What the fuck? So, thinking about this problem a little bit more, I think sort of greedily you want to pick the larger buttons, but I'm almost certain that there are solutions where the largest button doesn't help you. Large equals better. That tends to be how it works for some things, yes. What is your ugly sweater badge? Where did you get that from? This badge was earned for sharing festive clips during Holiday Hoopla 2025. Amazing. I think we also sort of know the maximum number of each possible button, so we could probably just iterate through all of them. Like we know the bound, like we know the upper bound of the number of times we could press this button based on these values here. And then I think we could narrow down the upper bounds of these other buttons and then just pick the best one. But I still think like we would be iterating hundreds and hundreds of times. But maybe that's enough. Maybe that's enough to get this down to a small problem. I mean, what is the longest number of buttons, I guess? $13 buttons. God damn. Rita X, thank you for the follow. Welcome, welcome. I hope you're doing well. Shows a mathematical way to optimize the problem. Oh yeah, probably. There's almost certainly there's some like fucking matrix solution to this that I just don't. I don't. I'm sure there's a lineage solution to this. But yeah, I also hate matrices, so I'm not gonna do it like that. Oh, why do we still have this function here? Okay, so I'm gonna try that idea and just see where it goes. Because this is just probably never gonna complete. You could also just guess the answer. I don't think that's a good idea. I need to somehow think how to make a generalized n deep for loop. of ranges based on I guess I could just represent it as a tuple that I get the values from. Kevin says, I wonder for yesterday's problem if you could find a GCD between all tile pairs while you just scale down the grid proportionally and just do flood fill. Apparently flood fill actually wasn't that terrible because the size of the thing ended up being small enough that people just did it without even scaling. But yeah. Like, I think it's not terrible to mark the inside outside. Like, the grid was like, yes, the grid was 2 billion, 10 billion pixels or whatever. But I think only a small portion of them were actually full. Flood fill wouldn't work for me. Kexus says there's an nlog n solution to today's problem. Well, that's cool. I'm not gonna find it. I'm gonna go with my idea and see if I can get it working. Oops. You guess it first try it's an O1 solution? Yeah. Kexus says I actually don't know if it's true. I mean, you're just making shit up, but it's probably correct. Yeah, this is where fucking... Does the matrix operator even do anything in default Python? I don't think it does. Where is it even? Yeah, I didn't think so. Did not think so. We sort of need this to be stateful, don't we? So we don't even iterate. We kind of know this-ish. We do sort of need it to be stateful. I don't think I want to fuck around with iterator shit. I think we will just make a... You're absolutely right. I don't even quite know what I need to do here. I need an arbitrarily length iterable that has variable bounds and generalize it. I don't know. Let's see. Like something like this. But anyway, what about vectorization? SimD's nuts. NumPy arrays. Kexit, what are you doing? What are you doing? Okay, so say we're looking at the first button for position 3. We know that at max it's 7 presses of that. So, Maybe. Maybe something like this. But I obviously need to fill in some of these functions. I don't really know what this is. I feel like we should also do the range in reverse direction, just so we try bigger things first, since like 0 of everything is really unlikely to succeed. This just seems like a really shitty way to write brute force though. I don't really know why I think this is going to be faster than the other solution. But let's, I guess, try and figure this out. I don't know that we need that. All right, bound of a button on a target. That seems sort of right. How is this gonna work? to say your name. Welcome to the stream. I hope you're doing well. Thank you for the follow. Why did I write zip here? So we need to multiply out each repeated bits, which we sort of already have. We sort of already have this with this repeat doodad here. We need to zip every I'm trying to be too clever for this. Why did it work the first time? I don't think this actually will go any faster though. In fact, I think it goes a lot slower. Hey, what's up, Maya Stellar? Yeah, it's not even getting the... Oh, I forgot to do this. So we don't know. Could have just been buffering. Yeah, I got the first solution pretty quickly. The second solution in some amount of time. I feel like this could be better at bounding things because we're still iterating through all of these products over and over and over, which is probably pretty wasteful. And I only have like an hour and a half. This third problem is the one that's kind of annoying. And why is it so annoying? It's probably annoying because these numbers are large. Whereas the first two, the numbers aren't that large, and so it computes them pretty quickly. I wonder if there's anything specific about these indexes. 0, 1. There's a lot of things that have 1 in them. 2, 3, 4. Yeah, because I think I'm essentially trying like billions of things here, and so it's never going to find the solution there. So I don't think this is right either. Super annoying. Like, I know exactly how I do this with Z3, but I need to come up with a solution that works for SQLite, unfortunately. So I need to actually solve this by solving it, not by just throwing shit against the wall. It's not consuming all my memory anymore though, so that's fun. But how do I improve this further? I mean, the obvious answer is I need to prune better. Like, I think as soon as I come up with a best, I should be able to prune. I mean, I am pruning here, but the iterator is still churning. I'm still gonna try stuff that isn't useful. Oh, I guess we also know... We also know a nice lower bound here too. So let's just say if some like if the number of presses is smaller than our target, we can't possibly reach it. Is that true? No, because one button can add 6. we could still have a bound of the largest button. The length of the buttons helps here a lot. Let's just say, let's do the other bound. So if some Kevin's heading out. Well, thank you for stopping by. Good to see you as always. So this should... I don't know why that breakpoint's there. This should be a little bit faster, maybe? Well, it got the first one like immediately, so that's a good sign. But I still don't think it's enough to make it go actually fast. So let's figure out how to make it lower bound. I don't know. This is I don't know the actual term for this, but that's what I'm calling it. Is it supposed to be less than or greater than? What is the thing I'm trying to do here? So our button presses... like if we did 5 button presses of a 6 length thing, we would add 30, and at 30 is greater than the total sum, then we know that it can't be correct. Actually, can't we even just say does not equal? Because it has to equal, right? It has to be equal. Because if it's not equal, we have bigger number. But somehow I don't think this is still enough to get our result here. But I do think we have another equation that helps us bound things better. Yeah, like we have another equation that we sort of have. Oh, I didn't write out my thoughts from before. So like the button lengths have to add up to the sum. So like A plus B plus C plus D, how many were there? A, B, C, D, E, F is equal to the sum of result. So at the bottom, like assuming we've done all this iteration, we're left with one button and a result. We know that the number of presses has to be equal to the sum of the result. So like if len buttons is equal to 1, then we only yield if tsum mod this is equal to 0, so like that limits the last iteration to just one thing. That has to be in a tuple though. Because that's the only possible value it could be at that point. I think we might sort of be cooking here. Igor, thank you for the follow. Welcome, welcome. I hope you're doing well. But I still don't see how we limit it, like when we're at 2 buttons. How would I think about it being at 2 buttons? E Beyonce says, who we hacking? The government. The government. As usual. We're hacking Christmas. Yes, we are hacking Christmas. Yeah, so like, how do we find a lower bound for this? Without analyzing everything else in the list. Because I don't think, I mean, looking at our input, like I don't think we ever end up with anything that's super unique. Like there's zeros in a bunch, there's ones in a bunch of them. There's only one with 2 in that one, in that example. But there's 3s in a bunch, there's 4s in a bunch. There's 5s in this multiple. What do we look at the next one? 0, we have a couple. 1, we have a couple. 2, 2 is in multiple 3, is in multiple 4, is in multiple 5, is in multiple, and then there's only 5. Yeah, so this one doesn't, there's like no uniqueness pattern to these, I think. Like we could probably figure out the rarest ones. I think part of the problem is I'm doing all this fucking adding and subtracting all over the place, when really I should just be treating these like I think if I just treat these like numbers, it actually makes this easier, or at least the math is simpler and I don't have to keep making and destroying objects all over the place. Oh fuck, we've solved a third one. I don't think we've ever solved this third one before, so maybe we're making progress. But there's fucking 200 of them. So, switch to PyPy time? I could also multiprocess. That would work. They are trivially parallelizable. But that's not gonna work for SQLite. But it is sort of interesting. Maybe I should change the buttons to, instead of being the indexes, be 0s and 1s. Because I keep having to like awkwardly convert between the two. Already at 3 is pretty good. That's true. That's true. Let's represent the buttons as 0s and 1s. Just because I think it's gonna simplify some stuff and maybe make the computation easier. What the fuck is this? Oh, we were trying to figure out the widest, the thickest button. Oh, I bet if we sort the buttons by size and we try the biggest chunks first, that might speed this up too, because then it just becomes a packing problem. But we don't know. Oh, we do know the size by looking at the sum of it. I'm gonna fill up my water and I'll be right back again. Hello, I'm back. I think just because I was like, oh, I should make a button class and then cache the weight because I'm gonna have to compute it all over and over. Maybe we do that. Torn on how to represent these. Maybe we'll just represent them all the ways. So we'll sort the biggest buttons first. I think that's what I wanted. All right. It's Alish. Thank you for the follow. Welcome, welcome. I hope you're doing well. Maybe I said your name wrong, but I tried. Help me learn how to pronounce it, if not. Unused. Oh. Wait, no. Where's my iterator? Oh no, we do chop off buttons. Okay, that's good. One MERS, thank you for the follow. Welcome, welcome. We can get a better bound here. Then I've sort of fucked up all my math by doing this. It's fine. It's fine. It's fine. It's fine. Shell 11, thank you for the follow. Welcome, welcome. I hope you're doing well. All right, let's just change this. Um. So that makes that easier. This I think can be written as return some parts or parts in zip. I think. Clearly not. Well, how did I fucking break this then? It's probably this guy here. That looks right, actually. Yeah, that looks correct. That looks correct. So that function's probably fine. We actually don't use size here anymore. So this seems fine. There's actually a better way to do this as well. Still getting the wrong answer. Okay, let's continue looking on here. This seems fine. Recursive call. Is add still used? No. Is this math wrong? Ooh, okay. This math is wrong. Okay, that told me something. The most that we could press is so the most that we could press this. The most that we could press this is 8 times. Oh, we do always need to add 1 to this. And actually, since we add 1 to both of these, we can do this. Okay, we've reworked the code. It gets the first 2 pretty quickly now. So that's good. But we didn't actually make that many. We only made 1 algorithmic improvement, which was this. Which is not enough. Damn it. Sorry, I just gotta make sure that I need to Oh, we computed the fourth one. We've never computed the fourth one. So we are getting further, I guess. And the fifth one. So I think this will actually complete within a few hours. But I think I'm not quite happy enough with that. So let's figure out better things. Oh, I got the sixth one. It's chugging. I think like somehow feeding this back into this machine is the important part. And I don't really know how to do that well. Because this is nice because it's just like a little fucking generator doodad. We just keep all the state right here. Time for overnight sleep stream. That's just computation. Yeah, but I have to port this to SQLite also, so like I need to actually have an algorithm that'll complete in some reasonable amount of time. And this is not it. But I need to think of ways to eliminate possible ones. I think this was good. SQLite is fast. We learned last night. It's kind of true. Kind of true. I think like one thing we would be able to prune is like if none of the buttons could actually like it's not possible to get values that are left. We can prune like an entire branch of things. But sounds annoying. That sounds annoying to implement or even to think about. I guess we OR all of the vowels of the buttons together, and if it's not equal to the boolean of the target, we just early return. I guess I could use max because I don't think you can true. Yeah. We're gonna use this cursed thing. Okay, that seems not right. Somehow? How, though? Why is this optimization not correct? So we only have buttons left that are index 3 and 2. And our target is this. So the target needs things in every column. Unless I didn't pass along. No, we passed along new target. That's weird. It's super weird. I guess we should see when it when it goes wrong. Actually, I should put a breakpoint here. So it said 11 for the first one. And what was it supposed to be? Supposed to be 10. So clearly we fucked something up. How is this possibly wrong though? Super weird. Ten, 12, and then 11. How is this not correct? Oh, because... Oh. My Twitch name says past noon, barely beer time. Unfortunately, I have to drive a friend to the airport, so I cannot beer time today. So I think strict equality is wrong here. It just needs to be greater than. How did you print a space? Oh damn, it chugging now. We got to 6 almost immediately. No worries, I got you covered. Hey, there you go. You're my stand-in beer. So what the fuck's up with the 7th one? Why is that one such a nightmare? That one appears to be a nightmare because this one is unique. See, this one should be easy though. Like intuitively, I know this one must be pressed 4 times. We could special case? That doesn't sound like a good idea. We could do that. It would speed it up though. I wonder how many there are that have a unique one. Let's see. So like we know that there's only one that contains 2 here. I guess I wouldn't do this here, would I? Ooh, and if we do this in the recursion... If we do this in the recursion... then... we just get benefits everywhere. Yeah, so how do we figure out if we are a unique button? Oh, I think this might be the last little bit to this. To really make this optimization go crazy. But how do we think about it? Let's figure that out. Robovato says, hello, hello. Chest hair was needed for this AOC? I mean, Kevin and Wilfred decided so. Maybe this is one function. Okay. And I think the idea with the counters is correct here. Something like this, maybe? We still have one running? No. I feel like maybe we should reorder the buttons so the unique ones are at the front. So we're still not getting that 7th one. But I do like this idea. Are we actually hitting it though? One, 3, 4, and 5. 2, 3, 4. So it must have been index 4 is not in any of the other buttons, but that's not even true. Oh, it must have been 5. 5's not in any of them, which is true. The problem is if we reorder them, then our multiply out here doesn't work so well. It don't work so good. So I guess I would unique sort here. Maybe we give them a uniqueness score. Exit says From import star, every built-in module on 313 and lender returns 5,174. And by built-in module, I assume you mean standard lib module? Because built-in means a special thing. So why did it change the order of anything here? So 1 has only 2 things, 3 has 3 things, 0 has 2 things, 2 has 2 things. It's deterministic. Oh, because 2 has 3 of them. I guess that makes sense. I don't know, let's see if that is correct and speeds things up, I guess. Where do I still have a breakpoint? Here. Still having trouble with that 7th one. Even though it should be putting this one first. What is it doing? Why are there 6 dots then? Which one is it doing? 6 or 7? Kill me. What? Oh, I wanted breakpoint. Duh. It's like, why didn't I hit my breakpoint? Because I didn't put one. Oh, Jesus Christ, what the fuck is this one? Which line is this one then? It is the 6th one. Oh, it prints the dot before it happens. Right. So just sorted them by size here, it looks like. Because there were no unique ones? Yeah, nothing really unique about this, so it's just gonna fucking chug forever. Which is annoying. I feel like I want this iterator to be nested in here so that we can prune on best. Perhaps. But this one's pretty bad, and I gotta go. So I'm gonna wrap up here, and we'll finish this next time. M. Pepin, thank you for the follow. Welcome, welcome. I hope you're doing well. My name is Anthony. I upload educational content to my YouTube channel, youtube.com/AnthonyWritesCode. Go subscribe there. If you missed any part of the stream, they'll end up on the VODs channel at anthonywritescode-vods. Go subscribe there as well. Join the Discord. That's where I announce streams. Come hang out. That's gonna wrap us up. Have a good one, chat. I'll see you around. Peace.